I'm going to demonstrate how to use the Spring Cloud Dataflow to build real-time streaming processing of tweets data that's streamed from Twitter and go through different transformations, get tabs, and is later on stored on the file system in log files, some special files in memory, hold and query it from there using the Gemfire memory data grid. And we can finish with some example of how you can use Spring Cloud Dataflow Analytics to do on-the-fly analytics on the streamed tweets. So we're going to build an application that takes tweets from Twitter, taps to Twitter, consumes tweets in JSON format. For this, the Spring Cloud Dataflow has out of the box a source component called Twitter. Source. Our first pipeline that we're going to build is to consume tweets and log them in a log sync module. Very simple. Having this in place, we can easily extend it by tapping and consuming the same JSON tweets that goes to the log and pass them through a script processor that converts those JSON messages into a tab or tab separated values format and stores them into a file. We can, so from JSON to tab separated or comma separated file format, we're going to use here a Groovy script to do this conversion on the fly as data is streamed from the Twitter. We can do the same thing, but now load the data in each row JSON format directly into Gemfire, which is in memory data grid system, and being inside Gemfire supports JSON natively. So, and expose a query interface called OQL, Object Query Language. One interesting extension of this approach would be to use the Gemfire itself as a source within Spring Cloud Dataflow and build another pipeline that streams data, selected data, let's say selected by the language of the tweet. Only the English tweets are going to be passed to Gemfire continuous query component and exposed in turn into a file or log. And finally, we can tap and perform some counters analytics, leveraging the Spring Cloud Dataflow, dashboard. So, as a user, we will be able to run OQL queries, explore the logs, check the files generated on the fly, and of course, monitor the Spring Cloud Dataflow itself. Let's jump to the demo. We have a zookeeper running. This is required for Kafka. Kafka is our binder of the message communication between the component and Spring Cloud Dataflow. Now, here's the Kafka itself running. Everything is running on a single node at the moment. Now we have a Redis, which is optional component, but it's required in the case when you want to leverage the Spring Cloud Dataflow analytics capabilities. And here we're going to start the server. This is on the local machine. You have an options to deploy it on Spring Cloud Dataflow, on Cloud Foundry, or Kubernetes, Google, a couple of other cloud providers. For the sake of this demonstration, it's running on the local machine. So the Spring Cloud Dataflow server is being started. The next thing, we're going to run the shell that allows, this is the simplest and easiest way to connect to the cloud and to the Spring Cloud Dataflow server and orchestrate and build streams and tasks. Okay. It's too quick to start the shell before the server has been initialized properly. Okay. If we check now, there is no any application or building modules that we can use to build streams. So the first thing is to load those modules that comes with Spring Cloud Dataflow out of the box. This is why to do this, it's just to load them or register them from a public repository, neighbor repository. It's application import, and see already all those applications are loaded up. List, plenty of sources, processors, and things out of the box. Next thing would be, let's build our first stream, which is the Twitter. Okay, stream create using the shell. Let's call it tweets, the name of the stream, and the definition. We're going to use the Twitter stream. This is out of the box source module, Twitter stream. And land this data that comes from the Twitter into log. We have to pass a proper stream list. Here is our first stream defined. It's still inactive, we have to deploy it. Stream deploy tweets properties files. So here I'm going to pass the credentials. Of course, spell it tweets. Stream list. Now it's been in process of deploying. And to make, I think this gives you a good example how the shell looks. Let's now switch to the web console, which is a little bit more friendlier to do similar management tasks. It's called the Spring Cloud Dataflow or user interface. We have just defined this tweet stream from the Twitter to the log file, which is being deployed. We can see that actually two modules are involved, and the stream is deployed. We can even check the content of this log that we've created. You can see that constantly new tweets are streamed and logged into the file. We've practically built our first stream, which is a very simple one from the Twitter, put in the log. Our second task, as we discussed it, is to tap this data let's call this Twitter TSV. Then we're going to tap tweets. In order to prevent misspelling again, I'm going to copy the entire stream definition and to explain what it does. It taps within the original definition. If you remember, the original one looked like this, tweets. And here, our new stream tweets TSV, tab separated values, tabs practically consume the same JSON format, pass the data through Groovy transformator processor, which is defined within this file, tweet delimiter Groovy. I will show it in a minute. And the output is stored into a file which is under this folder with this name, TSV tweets. Let me show you the content of the tweets Groovy file. PI tweets. Here it is. It's a Groovy which practically does one thing. It parses the incoming payload that comes on the fly, message per message, and converts it, parse the JSON and extracts certain fields like created at, language code, a retweet count, and streams all this information on the back as a single line with tabs to use to separate it. Okay, let's deploy this new stream and see what would be the content of the TSV file. So we can deploy it from the console, runtime. Let's see, now we see two additional modules were added. The transformer, which is tapped into the tweet stream, and the file where actually the output is being stored. Let's wait for the deploying to complete, and we can check then the content of the file. Seems okay. Nice. And here it is. Now we have a per row split file with few fields that were extracted from the JSON document. If we go to the stream definition now, we have already two streams, the main one that consumes the Twitter streams and log them into a log file, and the second one that actually taps into the first one in the Twitter stream, convert the JSON into row-based data format and puts it into a file. Let's reuse the same techniques, but now actually tap this JSON string messages into in-memory data grid, a tool called Gemfire, which would open us even more exciting opportunities to deal with the data and explore the data. So the first part of the stream definition looks very similar. We are going to tap stream definitions. But we're tapping the same tweet stream, and the output is now redirected to the Gemfire sync module, which is should be listening to this by this locator to this host and port. We're going to use the tweets ID as a key in our key value store, and the region or these data sets on the Gemfire where the tweets are going to be stored is called the region tweets, and we're going to use the native JSON format. So let's make a detour and go and start actually our Gemfire cluster running on our machine. We're going to do this bin everything to the Gemfire's command line console. Start locator, I'm going to call it locator 1, this machine. Next we're going to set the serialization mechanism for Gemfire to use PDX, and which would help us support natively JSON. Okay, configure PDX. Perfect. And let's start now a server, Gemfire server, which would hold the data. The last bit is to create the region, or this is the dataset holder, Gemfire. Okay, list members. We have a small Gemfire cluster running on with locator. This is the access point and a single server, and it contains a single dataset which is empty. We can check the content, select, this is OQL from region tweets, nothing inside. Okay, let's go back to our Spring Cloud Dataflow definitions and deploy this stream that actually writes in this region the raw JSON messages. Okay, deploy. If you remember, so we already implemented the tweetsters to this log. We implemented the script that actually creates tab-separated values and stored in the file. Now we are building the Gemfire stream. Let's see how far the deployment has been performed. Okay, still waiting for the Gemfire deployed. Seems fine. Now let's check the status here. Okay, we have a lot of tweets already in the Gemfire. Let's see what is going on. Count 122 tweets in memory data grid 57. Okay, let's try to get something a little bit more meaningful. ID from the tweet, user name, and the text of the tweet. Okay, this is a little bit better. We can say provide some conditions where language is English or Italian. Let's also show the language. We have only one Italian message so far. Let's check for German too, and I would assume that the majority are English. Okay, so we have a Gemfire running now. We can do even something more interesting. Now Gemfire contains already the data. We can use Gemfire as a source in Spring Cloud Dataflow, and in turn use a built-in model called Spring Gemfire Continuous Query. And this looks like this. Build yet another stream. A bit slow. So we call it Gemfire Continuous Query, which is a module that consumes from Gemfire with certain criteria. In this case, we put where, and anytime new data comes that matches this criteria, it would be passed to this module, and in turn this module would send it to the log file. Okay. And while this is being deployed, I would show you how also to leverage analytics. Just yet another pipelines. We're going to create two streams to analyze the language and the hashtags within the incoming tweets. The continuous query is being deploying. Okay. So again, we're tapping the incoming tweets, and we're defining two field counters, one extracting the language, and it's called language field, and the other extracting the hashtags text entities called the hashtags. Okay. Let's deploy those two things. While they're being deployed, we can check the content of the continuous query log. So remember, this was we used Gemfire as a source in this case, and less. Now data comes from Gemfire, which was actually landed there from Spring Cloud Dataflow from Twitter, but now this is only tweets that with English language are sent by the continuous query and in turn put into the log. Let's see. Okay, our statistics field counters are deployed, which means that we can now go here to our statistics, and it is loaded already. I haven't cleaned it from the previous charts. Okay, English is the dominant one. And now let's create another one for the hashtags. Field values. This is the hashtag, and we're going to use pie chart. Or better, bubble chart. It's more expressive. Okay. Data is updated every 2 seconds, and you see how new tweets actually change in the statistics, so it's real time you process the data. This concludes this demonstration.